Spaces. Rest of all, I think new, right? I think you are there. I think, right? Some of you. Anybody else? So yesterday we have seen a lot of applications in connection with deep learning, various type of architectures and other real-time applications. Today we try to take a case study and see how yesterday when I asked what type of data we normally use or to prefer to have deep learning models of various type. If it is a image type of data, we used to take motor imagery classification, motor imagery analysis like EEG signals when we take what type of deep learning architectures to see. So we take some example and see how to deal with those such deep learning models. And we also try to have a practical session where we try to record the brain signals and see how they are going to be used for various real-time applications. Right? Now to begin with, what is brain-computer interface and what is the importance of neurons? And eventually when we talk about deep learning, the other day we started with neurons, convolutional neural network, perceptron models, deep learning models, and various other advanced and conventional deep learning models. But when it comes to dealing with some biological neuron model, we cannot avoid speaking about human brain and what is the inherent connection between some deep learning architectures or some neural network based solution and what is the connection to this particular area. Before we speak all of them, what is the significance of this area? Let me just give us a motivation for that. Now you are working in various research problems, right? In different areas. When you are working on a specific problem, what is the first challenge you have faced? You may be working in some security applications for some security problems, or some cloud computing applications, or some medical imaging problem, or some other problem, sensor network issue. What is a common problem we face? How many of you are pursuing PhD? Many of you, right? How many are in first year? Right? Sir, what is the do you face any problem in terms of your problem statement or anything when you choose to work on a specific? Have your problem statement is done? Not yet done. How many of you are done with your problem statement? Problem statement is ready for your PhD. How many of you? I think only once raised for first year, and rest of all beyond first year. Na? So obviously you must be ready with your problem statement. How many of you in second year? Madam, your problem statement is ready? Then there is a serious problem with your supervisor. That's for sure. One of your mistake, whether you are. Within 6 months your problem statement should be ready. Only then you are. No, I'm not just criticizing. That's. So some area, some topic is that. No tentative, should be fixed. When we say tentative, our PhD is also tentative. We can't guarantee. That is the first failure. But I consider that is a failure of the supervisor, not the student at all. Unless the student is unstable. Having said this, okay, some tentative something you have done. Any problem you have faced? When you start with that problem statement, you have faced any problem? Yes, we got the answer. Data availability, data problem, data acquisition, right? This is a common problem in most of the areas, right? We have no data. Fine. And we always go to some Kaggle data sets or any other, some UCA repositories and other public repositories and try to take some data, download some open source data and try to see. Obviously they don't give the entire data, they just make it like a sample piece in a sweet shop. That's not a full data. And if you want more data, we have to purchase. Fine. So availability of the data is the common and the first problem in all your areas, right? Now when it comes to this domain, data should be available first to work in this domain. So whatever the problem you have, that should be the availability in this particular domain. Now what is the definition like brain-computer interface? What by name we can understand. We are making an interface between human brain and a workstation or a computer or something, right? By making an interface between these two, what we get? Interface makes what? Communication. By way of, see, there is a difference, the communication and interface, interaction and interface, there is a difference. Interface, we talks about how we are going to define protocols, hardware, software protocols, how the interface happens, how the communication happens between these two, what type of hardware connections required, what type of protocols to follow. Interface is beyond that, beyond communication. When an interface is created between two objects, you will have communication. Now, brain computer, there is a communication by way of an interface. So when they can communicate, obviously communication needs data, one way or two way. When we say the moment interface, we get communication. We get communication, we get data. Right? So the moment we are going to get data, now when we say brain computer interface, we get data from brain or computer. From brain we assume that. When we say normally an interface created, we expect communication to be bidirectional. But normally as of now, our main focus is just how to take data from the human brain and use it for various real-time applications. One side. Does not mean that the other way of communication is not at all done. It's going on. You have seen that Elon Musk, how that Neuralink project was seen, where they are going to make a small implantation of a chip here, which is connected to which is intellected by some nanoparticles to the neuron cells, and they are trying to control. That is like other way of communication, but it's very, very infant stage. Now, when it comes to dealing with such a communication, where we try to record large volume brain signals, right? Large volume brain signals, and store them in a workstation. That is one part is done. Now my interface is successful, I have recorded the data. What next? So the problem which madam said and somebody said in other domains, now it has become an opportunity for us. This domain I am starting with the data. But only thing is, before we start, you need to define what your application is. I am recording brain signals, right? When you are recording brain signals, you should record what type of signals you want. I am going to use it for some lie detection. Now see, if I can capture your brain signals, tell me what and all the applications we can address. Just one application you tell me.
You can find the age of a person based on the alpha, beta and gamma waves of the brain which produces.
Okay, that's an application. But for age determination, there are many other better advanced, like bone. They just take a part of the small piece of the bone and see based on that microparticles, they will generate the age more accurately compared to brain signals. So some anxiety or I'll call it as a mental state analysis, something like that. Similar way, right? Human contemplation, mental state analysis. Any other application? Lie detection. Lie detection, we have seen that with the movies where we connect and make it like lie detection. Any other?
Any neuro issues concerned with the person?
So I'll call it as a Parkinson's disease, some neurological issues, dopamine. Okay? Dopamine is not produced properly or inconsistently. There's a problem. That's again. So early stage detection of Parkinson's, that's an application we are already working on that. Like that, see, if you on this part we got 5-6 applications, right? Keeping the privacy and ethical issues aside, there are a lot of advantages. But question is, now the motivation we got it, the advantage we got it, we have the data. The moment I want to work, I have my data with me. Of course, you need an equipment like that, obviously. Then there's no equipment, again you have to depend on open source data set. Now I have my data, and I'm going to use it. Now why? The advantage is data availability. Significance, what is the importance of this domain? Some cloud computing application. I just come up with an efficient memory processing application. Some wireless sensor network, some energy harvesting or routing application. Some medical imaging, early stage detection of some so and so. But what is the importance of this domain? Is it like one among the others? Now if I come up with a model, based on my brain signals, if I say a person is lying or not with 100% accuracy, right? If I say whether a person is lying or not, what is the consequence? Is it a simple application like one among the other which we are talking about? No. All court cases are on a single day. If you can come with, now we often see in some court proceedings like they demand for lie detection test. Fine. Then why the judgment hasn't come so far? Because lie detection is not a legally accepted, that is just for preliminary investigative procedure. Court consider it as a secondary evidence, it's not a primary evidence. Fine. Court may not consider it as a strong evidence. Because why? Accuracy issues, error. Previous days, they used to take heart rate, pulse rate, there's some slight difference, and skin conductance, blood pressure, etc., to see a person, like the parameters for lie detection. Now, with other technology, when the electroencephalograph have come into the picture, people are taking EEG signals to say. Because when we say lie nature, concealed nature of the information, lie detection nature, comes from brain, not any other part of the human body. Right? So eventually, if you are going to use the brain signals and say that somebody is lying or not with 100% accuracy, if you prove that for any given subject, for any type of query, we are going to extract whether he is lying or not, then we are done. And if you say accurately, if you identify, that can be an accepted procedure legally. Then what will happen? It can be adopted and all the court cases are done in a single day. See that wider impact, which we don't have in any other domains. Right? Similarly, a lot of ethical privacy issues also will come when we don't allow somebody to read something from a human brain. Right? When I can say you are lying or not, it is also equal. I am going to extract all your thoughts and others from your human brain. If I want to read your ATM PIN number, is it possible? Tell me. I want to read your ATM PIN number. How it is possible? Is it possible? Now, can we convert this problem as a machine learning problem? Let us try. Yesterday we talked about some deep learning, supervised learning, right? Now we'll ask a question. What is the first digit of your ATM PIN number? How many choices we have? 10, 0 or 1 or 9? 10, right? Now, if I call a person and ask, connect some electrode wires and record his brain signals for every question, 10 questions I am going to ask. I will show some 0, 1, 2, after every slide I will show. I will ask whether 0 is the first digit of ATM PIN number, whether 1, whether 2, whether 3. Because no one shares the ATM PIN number, they will not answer, but their brains has signal. When a cognition comes, brain reacts. It may not come in terms of a voice output signal where we require some speech recognizer. But the thought is there, because you know what is the ATM PIN number, first digit. Then if I ask 10 questions, your brain give 10 signals. How many are positive signal, how many are negative signal? 10 signals. You have a SVM type classifier, binary classification, one of the very effective classifier. You know, how many classes we have? 2 classes, positive class, negative class. Is it not a supervised learning problem? Right? So we can see your ATM PIN number. Possible, same, right? Do you expect that different signal comes, not 9 and 1, something else? No. There are 10 questions I am asking, 9 of one type, 1 of different type. Why? You know only one number is your ATM PIN number. Brain acts differently to positive, differently to negative. 9 times different behavior, 1 times, otherwise brain is not functioning. 10 question, 10 signals, 9 are negative, 1 is positive. It's a classification problem, right?
Sir, the person should not know what we are extracting from him.
I understand. That is depends on training the subject and what type of signals we are taking from which portion of the brain and all. That I will come out. That is the problem. Now, why you are questioning? Because he is asking how to know which signal we are collecting, and he should think of that behavior. Subject will cooperate. That is how we train the subject, right? Why I am saying this? On an average, human brain has more than 70,000-80,000 thoughts per day. On an average, many of them we don't notice. Only few we think. On an average, more than 70,000-80,000 thoughts your human brain has, right? Now, obviously, he is right. Extracting those particular 10 signals from that many thoughts is not so easy. That is a challenge here. That is the reason we have not understood more than 1% of what the human brain is so far. What we have understood is less than 1%. Okay? So that's why it's very challenging. That makes this domain is very, very significant and very, very outstanding in terms of its applications. Right? That's why. And why it is? Because human brain is very uncertain. Very uncertain and difficult to process, difficult to understand its nature. As people say, like very difficult to read the heart of somebody. And when we say heart, people also say like on an average, how many beats per day? Heart? How many beats per day? Heart? thoughts. Human brain has said more than 70,000-80,000 thoughts. How many beats per day? Close to 1.1 lakh something, I think. Close to 1 lakh, I think, right? Brain, some thoughts per day. Heart, some beats per day. 72 multiplied by 60 multiplied by 60 multiplied by 24 something, right? Some close to 1 lakh approximately, right? If you consider 72 is the average, right? Now there is always a saying, if we consider human body as a house, people say heart is husband, brain is wife. It is because brain is a command control center, and obviously wife controls the house, many of the houses. It's true. And same time, it's very difficult to understand a woman. Like that, it's difficult to understand human brain. That's why we make it very uncertain. It's very uncertain. It's true. I know many of you boys also agree, but not now. Later they may agree. It's very, very true. Sir? Your madam is not there, that's why you're agreeing, I think. Now, then I think you are a very talented person in this world. Then, so now, no, the why I'm just matching is very, very uncertain. That is the reason this domain has lot of scope. Because there is a lot of chance to understand the uncertain, complex, inherent nature of the human brain, which gives diverse applications like what we have all spoken about. And they are not simple applications like that. As I mentioned, now you see, previously we used to have that magnetic that swiping cards, ATM. Now we have a magnetic tape, same time we also have a chip. You need not to swipe it. You can simply take it close to the swiping machine, it will read the card and your money will be debited. Now when it comes to such a level of research in this domain where you have not a wired interface, you have a wireless interface. When you have such a wireless interface to read somebody's brain, can you imagine what type of problem, all this problem, what I have spoken about for these lie detection and these ATM example, etc. All this will become true. It's true. We have already seen in some fiction movies like X-Men and all, right? But that is beyond that. When it comes to every fiction movie has a scope, like what is the possible research scope that can happen. Fine. Every such graphics movie was built based on such an imagination where the research can go all those Inception movie, X-Men movies and all, right? Therefore, this domain is not like ordinary domain. This has wonderful growth for next 2 decades. That's what I can say. And you need not to worry if I don't have a lot of biological background, etc. This hardly require a bit of biological knowledge of the human brain and its understanding and its cognition levels, plus some machine learning, plus a bit of signal processing. If you want to go hardware side, a bit of IoT. That's all. So now when we started with the convolutional neural networks and all, which we have seen the other day, class deep learning architectures and all, as we have specified yesterday, how the artificial neural networks are ruling the computing world. Now when we talk about the artificial neural networks developed based on the biological neuron models, just by understanding a neuron to neuron communication, how the cell body communicates to the other cell body of the neuron, and then how the enzymes and dead ends take place in the communication on the cell body, soma and all the work. Just by way of that a neuron to neuron communication, of course at a light speed, if you can understand the same biomimic behavior of the human brain, which is a factory of neurons, are you following me? Understanding the neuron to neuron communication, I have developed the artificial neural networks, right? If I come up with a model, a biomimic model, that's a biomimic model, right? Artificial neural network is the biomimic of the biological neural network. What happens if a biomimic computing model based on the entire human brain, right? Just a neuron, just some cell of a brain, you have got an artificial network which are ruling the computing world. What happens if you are going to completely mimic the computing nature of the human brain as a whole? You will have even supercomputing applications which can be done at a fraction of time, right? Try to understand how it happens, right? So people started often very crazy about using such a complex data from the human brain and understand the inherent nature for various real-time applications. Many of them we already spoken, 5 to 6, and at the end of the session I did some new application from you, right? So obviously where and all those deep learning architectures, extreme learning machine, genetic algorithms, swarm intelligence, optimization, GAN network, everything they use for those problems, right? Now to understand the human brain, we start with the biological neuron model. what is a neuron, how a neuron communicate, how a chemical reaction is made out of an electric signal, out of how an electric signal is discharged out of a chemical reaction. What reaction happens in human brain? You have studied, right, artificial neural networks? We have like potassium, etc. Some chemicals are there, right? We have a chemical reaction happens in the human brain that produces an electric signal, 250 miles per hour speed, that exchanges communication between neurons. Millions of neurons work, coordinate together to perform a specific task in the human body, right? So how we are going to capture such a neuron to neuron communication and behavior, and how they communicate at a junction called synapse, and how we are going to identify them, and specific to our application, like I mentioned, lie detection, specific to that application, how we are going to capture the brain signals. As I mentioned, more than 70,000 thoughts a day by human brain. How we are going to capture or identify or extract that signal which is needed for my application, that is a challenge here. Fine? So human brain, as I mentioned, is not a biology class. Same time we start with a little bit of biological aspects about human brain and all. Let's recall our childhood days and biological class, and biology class which we studied long back, and biology to psychology, how a human brain works and how people take the brain signals, how brain signals behave. From psychology to computer science application we have. Okay, biology to psychology to computer science application we have front end. So now, as I mentioned, it's not a biology class. Same time, you have some basic understanding of the human brain. Fine, only then we'll be able to, as I mentioned, I have to record the signals of some lie detection nature, human contemplation, mental state analysis, early stage detection of Parkinson's, brain stroke, epilepsy problems. To see, first we need to understand where I have to take the brain signals from, right? So we need to see what type of lobes we have. Brain has normally either hemispheres, left and right hemispheres, and each hemisphere has 4 lobes: frontal, occipital, parietal and temporal lobes, right? Each lobe has certain predefined functions. For example, if you see emotional control, which part of the human brain is, or which lobe of the human brain is responsible? Tell me. Emotional control. Speed of, you can say, visual information processing, hearing functions. Tell me, we have different emotional control. Which lobe is, I think, must be frontal lobe, right? Now I'll give you a simple example. What type of this beauty of this domain? There was a person in I think United States of America. He was sentenced to death because he committed some severe crime. Then what happens? The court of law sentenced him to death by hanging. He was almost died. Before he was hanged, a day before, the advocates of him went to the court of law, showing the MRI images of the person's brain and claiming that the person has some problem in the structure of the frontal lobe, and frontal lobe is responsible for emotional control. If you see the last but penultimate point, I think, emotional control. Because of that particular structural problem in his human brain, frontal lobe, he has committed the crime. He was not intentionally doing that. Then court convinced with the argument, and then maybe some other punishment he would have got, but not lifetime imprisonment or something. But he was escaped from death, right? You see where MRI images, where BCI, where machine learning, etc., etc. How such an interface was made. Every such an interface, that is part of the human-computer interactive model. How we are using them for various applications like this. So before we go to deal with any application, we should understand what type of signals are there, from which lobe, which hemisphere, and how many channels. That more than we have about 250, 260 channels beyond. We have identified so far representing different cognitive nature of the human brain, right? Normally when a person is concentrating, most of the frontal lobe region is active. When you are making some facial expression like eye blinks, laughing, crying, etc., where the facial expression take place, frontal lobe is more active. It's often observed something like that, right? So how we are going to understand such a behavior? Only then, like we cannot switch on a fan and expect light to be on. Unless you know where to record the brain signals, you cannot make any application out of this. I'm not going to go deep biological aspects of the human brain. I leave it to you. You can study on your own in case you want. And similar to EEG, we have fMRI data depending on the changes of the blood flow in the region of activity of the human brain, how it is going to be seen. fMRI, NIRS, CAT scan, PET, etc., etc. There are various types, but they are all of brain, from the brain. Okay. So now many of you know, I need not to highlight, there are some ethical protocols you have to follow when you are going to record some brain signal for this, like there should be an ethical committee in your college or institute, and you need to submit your research proposal, what type of subjects you are going to take, how many records you are going to, how many subjects, for what purpose, etc., etc. Everything you have to submit a proposal, they will approve. Okay, and it's invasive. Now mostly we go with non-invasive mode. Okay, normally invasive mode is performed by some medical practitioner, doctors, etc., etc. Normally we don't do. Okay, so if you see brain, that I am going to record some brain signals, brain is safely located under multiple layers of protection. We have scalp, skull bone, dura mater, periosteum, subdural space, many layers it is safely located under, right? So normally we connect the electrode wire on the scalp, under which we have skull bone, then subdural space, periosteum, all those things. Now that is non-invasive method. We just connect the electrode wires here. In case of invasive mode normally that is for some surgical operations and performed by doctors, medical practitioners, surgeons. When they perform some complex, normally if you, I don't know whether here or not, when they perform operations to brain, they keep the subject alive, awake. Because normally when sleeping mode, they avoid performing operations to the brain. That is to keep the brain region active such that the chances of getting the operation successful are high. Fine. So something like that. For such an operations, like where they are going to take the data from the invasive mode, but most of the time we take from the non-invasive mode, where we directly take from the scalp, not from the skull, not after cutting the skull bone. Okay. Having said this, when you are working on some small problems like lie detection, etc., etc., don't call a person and break his head and tell my name. Okay, because we are going to have non-invasive mode. I am clearly mentioning. Okay, don't never ever attempt any invasive mode and tell my name. Okay. Now, as you mentioned, because multiple layers of protection for the human brain, eventually when we are trying to record the brain signals, lot of artifacts and noise could be seen in non-invasive mode. Invasive mode it could be very less, but as you mentioned, we are not going to do that so easily. That is to be done by the experts. So we need an amplifier that typically try to amplify and filter the signals about 10,000 times. Right? Amplification. Okay, that's a part of your signal processing, that's fine. Okay, so how noisy signals can be amplified to have a better quality signals, etc. So this is how the entire, I think it's not moving, slide, yes. Now, so this is the entire, like we have my BCS system and we have my subject or patient, and a subject in this is like anyone, like lie detection, etc., etc. Patient we call him for some medicinal application, and then we have my BCS system where once the input signals are given to him and the front end device is connected. It may be like I mentioned, lie detector or some medical application, medical device, healthcare technology device, like a smart wheelchair for a paralyzed or locked in or immobile patient. Different, almost same. Fine. Maybe a paralyzed patient. Okay, logged in or immobile, and your job is what type of signals you are collecting from which type of patients or subjects, how many channels, how many trials, how many records. Then once your BCS system is ready, using that input signal, whatever the classification, feature extraction, signal processing, pre-processing, everything you perform and make the front end device to be automated by those signals. If it is a real-time signal, real-time automation of those devices. Like a smart wheelchair. A person is sitting on the chair who is paralyzed, you can control the wheelchair operations without any assistance. Something like that. So the entire operating environment, we have a subject connected to the amplifier, where subjects, an electrode wire is connected to the amplifier. One end point of the electrode wire is connected on the scalp, other end point is connected to the amplifier. So brain signals are captured by this electrode wire. There is an electrode gel we used to apply for easy passing of the signal, and whatever the captured signal will be amplified about 10,000 times and filtered in. Then it will be stored in the computer. There is a feedback screen to see the quality of the signal which is captured. Then trial 1, same subject, trial 2, same subject, trial 3, trial 4, trial 5, we take normally 15 to 20 trials. Then we call the second subject. Trial 1, trial 2, trial 3, trial 4. We see the feedback screen. We need to give some subject to stabilize So you can discard first 5 trials. There are some experimental process according to type of applications, etc. So you can discard some 5 trials first, keep the next 10 trials, something like that. So some like what you have wastage you have. Then you can call the next subject, trial 1, trial 2, trial like that. Finally, there is an easy controller to look after the entire operations, something like that. There are some software tools exist. I will just give a demo. And some applications, as I mentioned, there are various type of application. Neuromodulation schemes for various healthcare and biomedicinal application. We have deep brain stimulation, vagal nerve stimulation, transcranial magnetic stimulation for these type of problems. Each has a different, but this is purely biomedicinal, biocomputing applications, etc. We will just see them. Deep brain stimulation, normally a person with some epilepsy problems, brain stroke, Parkinson's disease, how the dopamine levels are being maintained, are monitored, and then whenever there is a problem with a particular cognitive, location of the person's brain, we are going to have an implantation of electrode wire in an invasive mode of data acquisition, where an electrode wire is attached directly to the human brain, and we are not doing that. This implantation is done by the organizations or medical experts. Then there is a battery pack running out of the neck, and you can have a replacement of the battery. It's not exactly like a pacemaker application, something else. Then you can monitor the brain signals real time and see what exactly the problem. You can classify whether it is a Parkinson's or epilepsy or brain stroke. Classification of the disease, or accurate detection of epilepsy or Parkinson's or brain stroke. Fine. Or early stage detection of Parkinson's, monitoring of the dopamine levels, etc., etc. Plenty of them. Okay. And how to monitor these compulsive disorders, etc. There are some challenges, and similarly we have this. Normally, if a person is having some depression or drowsiness, etc., etc., some medical complex, some psychological complications he is having. Some treatment like TMS, transcranial magnetic device treatment. What we do, we try to trigger the neurons in that specific region of the human brain, which is responsible for such a drowsiness or dullness or any other mental complications he has. When we trigger the electric fields, when we trigger some electric fields in that region, the neurons in that region becomes active by the magnetic fields created by the triggering, by using such a device. Then what happens, those pulses which we create, they trigger the neurons in that region to become active by using those electrical charges created by the triggering. It is like you are artificially making them active. It is as good as like you are giving training for some every week 1 or 2 sittings, and then at the end of 1 to 2 months you are going to see some change that. So another complex problem like measuring the influence of the TMS treatment for the person with some mental related issues like some psychological issues, anxiety levels, depression. So how this particular treatment can be used to ease the depression? By monitoring. Normally what we do, when a person is going for this type of sittings, like before sitting, record the brain signal, after sitting 1, again sitting 2, next sitting, maybe in a week 2 sittings we have. Before sitting, after sitting, see the brain signal. And for 2 months span, at the end, be first sitting to last sitting, how the signals are going to be improved, how the brain region of that specific part will become active. So it is like monitoring the influence of the TMS device for some mental state analysis problems, mental state problems, mental disorders to deal with, all those applications you can have. But again, this is required some medical assistance, because you cannot, to check that it is working or not, you cannot call somebody and apply this one. A person with some psychological problem who is undergoing such a treatment, with due consent you record the data. To check whether this application, don't call a person and apply, a normal person becomes abnormal. Right? So it's a very, very important how we are going to use that. Okay? But sometimes some open source repositories exist, but not always. And similarly some lie detection are these IoT applications. how a smart prosthetic, neural prosthetic device can be developed. This is one of the very, very important. Lot of research is going on in a good progress. Unlike the other, like light detection also is good progress. Very quite conventional. This is very, very, hot topic now. Prosthetic devices, developing an efficient control algorithm for this one, using the real-time brain signals. As I mentioned, how the brain signals are captured. As you know, when I touch a hot object, I immediately take my finger back. How it is going to be seen? The moment I touch a hot object, my body generates the data recording. What amount of heat I'm going to sense upon. The moment I touch a hot object, my muscle receptors or nerves, they carry forward the information of the amount of heat which I touched. They reach from muscle receptors to spinal cord, which abridges the communication all over the body via central nervous system from human brain too. Then what happens? Your brain knows what amount of heat your body can tolerate. Immediately you have an action potential. Again from the spinal cord to the muscle receptors tells you take your finger back, a command. Then you take it back. But unfortunately here what happens, the muscle receptors are missing here to carry forward the brain signals, neurological signal. Fine. Then what happens? You're going to have some EMG signals captured from those electrode wires which are connected here, and then again interconnected to some Arduino or Raspberry Pi. Program it in such a way how the real-time brain signal is captured and processed, and based on them how the device is going to function. Fine. It is as good as a real-time system based on real-time brain signals, how you are going to make an accurate device that works exactly like the natural one. Okay. This is one of the very important ones. You can have a smart IoT application for some healthcare technology using these neural prosthetic devices, etc. But here you have to capture something called motor imagery signals. Motor imagery signals. What is this motor signals? Anybody knows? Motor signals. In brain we have something called motor cortex, right? Motor cortex, which is looking after all the movements or the physical actions which our body performs, right? Which our body performs. Motor cortex, very, very important in making all such physical moves or operations or tasks which we perform. Now, why we call as motor imagery? The person's limb is not present, and he is going to imagine that his limb is going to function, but there is a disruption to the signals of human brain, the neurological signal. How the signals are going to, that is called as a motor imagery signal. Fine. So they are motor imagery signal, and we use some deep CNN or some CNN architecture, fractal net, AlexNet, DenseNet, etc., GAN networks to deal with those motor imagery signals to identify and successfully capture those signals for various, classification procedures like this. Okay, any doubts? Similarly, we have retinal implants, but it's very preliminary, it's very hard to deal with because the fixation of the electrode chip here inside and connecting to the optic nerve. Normally, how the vision system inside your human eyeball is going to be useful to you. When your retina captures some information with the help of the cornea that is inside, and it is immediately directly sent, like we have something called an optic nerve connected to the cornea. The moment your retinal structure captures the lens, the cornea, when it is connected to the optic nerve is going to directly connected to the human brain, right? Now there is a clear connection between the vision system to the human brain. Normally when there is an issue, the main problem here is this optic nerve is composed of lakhs of micro nano nerves. Now the main problem is not availability of the eyes. Now how many of you know when we are going to donate eyes? Are we really donating eyes? We never donate eyes. Only the inside that cornea, retina, only we used to donate. The entire optic nerve connection is not yet done. That bypass connection is not yet done. Otherwise, many of the people would have survived, gone back with their vision system. The main problem is they are unable to connect or make a bypass connection to the optic nerve, which is direct connected to the human brain. So whatever the capturing you are making with your cornea, it is going to be directly seen by a brain via some screenshots, some frames. It has a lot of our human eye has, I think, about 512 megapixel or something, more than that, more than any of your mobile phones. Fine, I think 526 megapixel more. Now, the main problem is this optic nerve is composed of very nano particles, nano nerves, which are very difficult to observe and integrate, or you can say bypass. That is the reason they are unable to make the solution to send these whatever the frames you are capturing to the human brain directly. Are you following me? So there is a challenge here, how to deal with them. So there is a lot of preliminary research, but actually recently MIT has developed, I think, some small chip which can generate, because the main problem here is when you are making a fixation of a chip here, every such electric device or electric component makes generation of a heat, whatever the amount it is. Even in such a micro heat also, I mean the very small amount of heat cannot be tolerated inside your eyeball. That is a major problem here, fixation of such a chip. No, but recently MIT has developed as micro nano chip which deposits only very minor ignorable amount of heat which the eyeball may tolerate. So with that invention, maybe it is possible to have such an integration over the time later. But for now, very in fact I don't go there. And some other applications. And as we mentioned, like this is not a very new topic when we talk about brain signals. In 1929, close to that, somebody has observed there is a magnetic field being seen around the human brain. So some type of signals are being observed at very long back. Right? But unfortunately that time we had no sophisticated technology to deal with and to understand and to compute and to process those signals. Therefore, I think we never focused upon much. But now with the increasing of better big data analytics and the artificial intelligence techniques, same time cloud computing, memory management aspects, it has become possible now to deal with all such complex signals which were observed long back. So some of the signals, benchmark signals, which we see alpha, beta, gamma, delta, etc. etc. Normally when a person is alert, we used to see beta waves. See, now we need to understand very importantly these different states of vigilance of EEG signals. I think as madam has somebody already talked about alpha, beta, gamma. When you understand them, like it's very unless you understand this benchmark behavior, you will not be able to deal with the applications of human brain. So when we say alpha, we have relax, beta, alert, and then theta sleeping, deep sleep, we have REM signal, and then delta waves, we have paradoxical sleep, we have REM signals. So everything has an application, like when we say. Can somebody give me an application using them? Anyone? Using alpha, beta, delta, or REM. Any application? Which one? Alpha, beta? What is that?
If alpha waves are relevant to the relaxing waves, if its intensity was more, we can say that the person was.
So the more alpha is there, we can say that he is not stressed, he is the relaxing guy. I think no, that's fine. Okay.
Based on that, we can understand.
That's fine. Any other? Any better example? Are using alpha, beta, theta. For example, driving. Normally when we are driving, we should always experience what? I think beta waves. When we are driving, the driver should be very alert. Beta waves. When the road is almost empty, he can relax for a while. When again some other vehicle comes, he can have again beta waves, alert. Right? Can we have delta waves? Normally when somebody is driving, he should not have any delta waves. If he see delta waves, he will not be seen by anybody. Right? So, if we have a smart, nowadays see, we're talking about autonomous vehicular systems and all autonomous vehicles and driverless vehicles, and obviously we can easily communicate to a vehicle. Every vehicle has a processor. right? Every machine in the world has a processor. So now we can interface to a vehicle, our car, right? Eventually what happens? We can see if you are going to see like a person, we can have a smart like easy cap type where there is a single channel easy device is there, and it can be integrated by a wireless mannered application by your, to your vehicle. Then the moment you are experienced with the theta waves, vehicle should make an alert mechanism, have an alert mechanism saying that you are sleepy. Immediately stop the vehicle and take rest, and the vehicle should automatically stop within a minute, and so that you can take a left turn and stop it in the parking mode. And when the person can take a rest, take rest for some time and relax and become normal, only when again we seen with alpha or beta waves, only the vehicle can start. It's an automated vehicle controlled by the brain, real-time brain signals. Quite possible, right? So what is the title now? A safe driving system using brain-computer interface and machine learning. Something like that. Not exactly, right? That's an application. Many have done it. Not a very new application, but something we can do, right? And similarly, REM signal, dreaming, we call as a paradoxical sleep. Dreaming we call as a paradoxical sleep because anything we imagine in a paradoxical world. So normally if I say like whether you had a dream the other day night, you can answer, right? You can answer. Can anybody else answer whether you had a dream the other day night? Nobody else can answer. But can you answer what time you had a dream? No, we don't remember. Before you are going to bed, if I connect the electrode wires, next day I can say what time, the moment I started seeing the REM signals, we can say what time you had a dream and what time it ended and what time you had, what is the duration of that. Where you can't answer. For such a paradoxical analysis we have. So that's a different research. Every such signal has a predefined ranges, alpha 13 to 30, and which normally seen frontal lobe and parietal lobe, and similarly beta. Alpha 8 to 13 edges normally seen occipital lobe, etc. Everything has. And similarly theta 4 to 8 edges, children and sleeping adults. Sometimes there is a saying children and adults are same. Something like that, and etc. etc. So many people have used it such an applications for interface and the whole operating environment. I think we'll stop it here because we need to just have a look at the brain signals. As I mentioned, the easy cap 32 channel or 64 channel, etc. etc. We have a easy cap where we connect the electrode wire. Each hole represents a channel position. Okay, different channels. There are different type of thing. This data acquisition procedures. And wireless EEG devices. Wireless. Now this is wireless device. Maybe I think 1, 2, 3, some 5 or 6 channel EEG device. It appears to be. Okay. It's a wireless device like a headset where we connect the brain signals and use it for all those applications what we talked about. And this is a single channel. It's a single channel EEG device costing around 18,000 rupees. In Amazon it is available. It was 18,000 for 1 year before. Maybe close to 20,000, not more than that I think. Now if you see, that's a single channel, not this one, this one. Okay, don't see the iPad. This one I'm talking about. Okay, it's a single channel wearable device, EEG wearable device. Okay, and similarly some virtual reality game playing applications. Not only healthcare applications, not only so, you can use virtual reality, healthcare applications, and many other applications. Having said this, what is the future of this? Before we see how a data acquisition happens, what is the future? Future, as I mentioned, ethical and privacy issues will come. I don't want somebody to read into my human brain. Fine. And many privacy issues are concerned. Particularly, now who maintain more secrets? Male or female? There is a lot of debate. Okay, I'll ask the same question in a different way. If your mobile phone is lost, who don't eat food? Males or females? Females. No, there is nothing wrong in it. Nothing wrong in it. Day mobile, I'm talking about. No, there's nothing wrong in it. I am saying this either ways, with all due respect, either ways. Now, when we talk about the ethical and privacy issues aside, a lot of things, because when we allow somebody to read our human brain, everyone needs privacy. But when this goes to such a level of wireless technology, when we talk about without even knowing that we are connected with such a connection and somebody is reading our bed, it's not only reading some ATM pin number or not, we can have next level encryption by OTP. Problem is not that. Everything becomes open, world becomes robotic. Fine, that is the level of imagination. Same time, and not only that, for example, over the time, now when some two people are, a boy and girl is going to marry, now sometimes diagnostic test reports, like whether they are physically fit or not, that's already existing practice, there's nothing wrong in it. It is our right to see whether they are fit or not, right? Same time, I also want to see whether he is mentally fit or not. It's an existing practice for not for marriage. Some companies, before giving the offer letter, they are going to go for some, after technical round, HR round, then before giving the offer letter, they go for some psychometric test, right? Now it may so happen that now we have shortage of sufficient women for like 1,000 male. We have, I think we are close to 950, 960 only we have. It may so happen that in future they may also prefer to have the psychological test before they go to marry. Quite possible, right? Why? Because now there is an example. Once I think a boy and he is along with the parents went to the girl's house. Before marriage, normally they speak, right, to see. Then the parents of the girl asking the boy whether do you smoke, he said no. Do you drink? No. Any other bad habit? No, I have no bad habits, only I lie. Then everything is lie what he has told, right? So it's a common practice. It may so happen if this research go to such a level, I also want to see his brain signals and see whether what he is saying is lie or not, right? Because everyone wants to marry a honest person, right? Now normally there is a saying like wife want a caring husband, husband want an uncaring woman. They don't want to care every time you call and say had you food, had lunch. They don't want. Wife expect a caring husband, a contrast behavior, right? It's true. What I am speaking is true. Nothing wrong in it. Everything is true, right? Now these ethical and privacy issues will be at such a level when this research goes to such a level of imagination, right? So we start with this and we just try to see a small data acquisition because to have some practical flavor of this one. And then what and all we have spoken yesterday, all the deep learning solutions, because I have talked about today motor imagery type EEG signals and non-imagery type. So you can use CNN or other deep learning architectures, either ways. Fine? Conventional perceptron model or other backpropagation algorithms or advanced deep learning architectures with multiple hidden layers or CNN based architectures. Fine? Okay. So I'll be just now we have an equipment, small equipment. I will just explain how it works. If time permits, I will just spoken about the other day and today. Now, if at all your project or problem statement has, requires data from at a time more than 60 channels of human brain, then this is not sufficient. But normally for a typical application, up to 16 channel is sufficient. What we have done even for light detection also, we have experimented about 8 to 16 channel, not more than that. So 1 to 8, 9 to 16. There are 16 channels data acquisition system. So I can record at a time from 1 to 8 plus 9 to 16. Total 16 channels I can record the data from. Typically for these small applications what we have spoken, they take around 16 is sufficient. We have 32 channel, 64 channel and even higher versions also available. This only costing close to 15 lakhs. Only this one. But different rates are different from make to make. Okay? Now what we do? I'll just explain how this works. If you want to really see the brain signal center, one of you come here, I will connect and you take your brain signals. Either ways. Okay? Or I have some video lectures, anybody. And I have some video lectures that also I can demo where we have already recorded. Either ways. Okay? So now, so we have a 32 channel easy cap which you normally keep on the scalp, the person's scalp. Fine. And we have each of this one representing a channel position. We have as many electrode wires we require, that many we have, sufficient number. Then if for example today just for a demo, if I taking data from frontal lobe, why? Easy to see, because I mentioned that facial expressions are easily be captured, the behavior from the frontal lobe, right? So when somebody is blinking the eyes, or when somebody is laughing or crying, etc., facial expressions can easily be captured from the frontal lobe. Frontal lobe is more responsible for facial expressions, right? Then I'll just attach this easy cap and connect maybe some two channel, like this is FP1, this is FP2. FP1, FP2. We have predefined names for each channel. I'm taking from these two channels, then connect the electrode wires to the amplifier and the scalp. So two connections here, two connections here, first and two. If you are going to have 4 channel, then first 4, 6 channel, first 6, 2 channel, first 2 you have to make. If it is 10 channel, up to 1 to 8, 9 to 10, that 10 you have to collect. Fine. If you say 2 channel and go for the 3 and 4, you may not be able to see the brain signals, because 1 to 0 always is a constant signal. Okay? Got it? Then what happens? There is something called an electrode gel. An electrode gel which we need to apply here, which we need to apply for the person whom we are taking the data from, the brain signals. Subject, for example, today subject is somebody. Then when we connect this when we attach the easy cap, we apply the electrode gel. Okay, we applied the electrode gel. Now I believe the girls drop, those who raise the hand when we say we are going to apply electrode gel, right? Then we connect the electrode gel and attach the electrode wire. Then other end we connect to the amplifier. Fine, other end we connect to the amplifier, right? Something like that. Duplicate second screen only. So something like that. Battery is no problem. Okay, then can we show video? Recorded video undi chupiddama. Better is not connect kakapothe recorded video undi adi chupichidam. వేరే ల్యాప్టాప్లో ఉంది, అది పెట్టండి ఇది తీసి పెట్టలేదు కదా, ఆ ల్యాప్టాప్లో ఉంది వీడియో వచ్చిందో. ఇది ఒకసారి కనిపించారా? రావట్లేదా? విండోస్ కదా, విండోస్ channel easy cap. The 32 channel easy cap means what? You can have almost maximum of 32 electrode wires can be connected. Now this amplifier has 16 channels only. So any 32C16 combinations you can have, right? 32C16 combinations of data recording you can have here. Now if you see, I have connected the easy cap here, and I am applying the electrode gel. You see how we are attaching the electrode. So simply apply the electrode gel and fix the electrode wire in the channel position. Right? This is how we apply this. and there is a reference and ground connection. There is a reference and ground connection. How we, if you are going to have two channels, first two channel we are going to collect, which will, like as I mentioned, first I select the channels like FP1, FP2 as I mentioned. Now if you see in this amplifier it will show, and even on the screen also there is a brain vision recorder and analyzer. On the screen it will show how many channels are connected, and if you see the outside are reference and ground, this is FP1, the sharp edge indicates forehead. Sharp edge indicates forehead. So this is FP1, FP2 on the forehead, the frontal lobe. Why I am taking frontal lobe is frontal lobe channels are more active when we make facial expressions, right? Now, but still one of the channel is still showing red color, means that channel fixation is not done properly. Unless it becomes green color, normally we don't record. So we need to apply a little more gel. You see, after applying little more gel, now if you see, it has become, the color is changed. Now both the channels are ready to record the signals from those whatever the channel position we have selected for that. See there, if you see there I am setting the channel like 0, as I mentioned, we have shown that alpha, beta, gamma, delta, everything ranges 0 to 5, 5 to 8, 8 to 13, right? Like that now we are going to set the ranges so that we can filter which channels we are going to record, right? With the predefined ranges, only those signals will be captured which you are going to, need from them. Now see, the two channel that I have mentioned, right? If you see there it is mentioned FP1, FP2. FP1, FP2, that is the brain signals of that person who was sitting there, the subject. Right? If you see, though, that is the real-time brain signals of that person who is sitting there. He is the subject. Now what are those spikes? It's artifacted noise because I was speaking there. During data acquisition, normally we should not switch on the light also and fan. Even AC also we should switch off. Even laptop also you should not run on the continuous power supply, you should run on the battery. That also creates artifacts, noise. Now as I mentioned in the beginning, trial 1, trial 2, and you ignore some first 5 trials, something like that, right? If you see over the time the subject stabilizes, his cognitive thinking stabilizes, then you record the brain signals. If you see this, how we are going to record. Now see, you know what are those four spikes? This spike, this one, that one, and that. Those 3 or 4 spikes. I ask the person to blink the eyes 3 times. Who is sitting there, the subject? I ask him to blink the eyes 3 times. Why? Now when he is blinking, because frontal lobe region is active and we are recording some of the frontal lobe, the FP1 and FP2 channels are more active, and you are going to identify the person's facial expression so easily. Eye blinks, smiling, crying, and all any other facial movements can be captured by those channels, as I mentioned. Now if you can imagine, when they are blinking the eyes, if you are going to capture the details from the brain signal, the behavior, eventually what and all the example we have seen, the capturing the ATM pin number of somebody and all others, quite natural, possible. Only the accuracy or error matters, right? Maximizing the accuracy, minimizing the error. That is the only challenge, right, we have. Now So you have taken some previous data which was already captured from multiple subjects. As I mentioned, a lot of tools are there for pre-processing, etc. What is there on the screen is the brain vision analyzer software tools. Now obviously what happens when we are going to record, if there is a lot of noise, if you can observe how the noise was pre-processed and how we are going to see a better one. You see, noisy data you see and pre-processed data. Just we need to set some ranges, how much amount of noise you see. Just set some value and see how it becomes. See, this is actual data. This I think some 5 to 6 channels. 1, 2, 3, 4, 5, 6 channel data. I am setting certain ranges for pre-processing. There are some filters, low pass filter, high pass filter, lot of filters are there. Set some ranges, or you can define your own filter also. Set the values and simply, there are a lot of tools like your MATLAB tools. Okay, see, these are the pre-processed data, pre-processed filters, before pre-processing and after pre-processing. You see, this is before pre-processing, same you see after pre-processing, how it happens. Now you see, over the time you see, first lot of noise and artifacts we have seen, over the time see how stabilized, because the subject was adopting the cognitive behavior according to whatever the experimental procedure we have, and eventually you will be able to say better quality signals there. That's all. Just have a rough idea about the experimental process. I want to connect and show, but I think the project is not connected. If you want, you can come and check, or if you want to connect yourself, I can help you also. Or any doubts, you let me know. Cheppan, no problem. Which one? Oh, it's working. Only thing is project is not getting connected. I tried for like 10 minutes, that's why I thought I'll just play a video file and show them. Which is working. It's a working device. If you want, I can record your brain signals and show. It's a working device, only your prop. I think this screen has a problem to connect, they could not do. So I have shown here. I brought all the way to record the same, whatever I have shown on the screen, same I thought of doing with any one of you. Some madam is interested to see her signals, but unfortunately we could not do. No problem. If you want, you can check, or any doubts, you let me know. Laptop కనబడుతుంది మేడం. ల్యాప్టాపే కనెక్ట్ కావట్లేదు ఇక్కడ, అందుకని మళ్ళీ ఓన్లీ ఇఫ్ యూ వాంట్ టు చెక్ ఇన్ ల్యాప్టాప్ యూ కమ్. ఫైనల్ ప్లీజ్ సేమ్ యూ వాంట్ టు చెక్ ప్లీజ్ కమ్. You want to check once? You want to connect, you want to record the signals also for you? Acha. Then one of you come and help me.
Two electrodes can be stick on the both sides of this.
I'll fix it. You sit here.
Sir, break, sir. First
Not wait, I think you have to leave now in 5-10 minutes. I'll take. Yes, just you need to keep like this. That's all. తీయండి మేడం ఒకసారి, అది తీయండి.
సరిపోతాయా?
4 తీయండి మేడం, 4 తీయండి ఒకసారి.
త్రీ కలర్సే ఉన్నాయి మేడం, ఏదో ఒకటి డబుల్ కలర్.
ఇప్పుడు జస్ట్ 5 minutesలో ఫాస్ట్ కనెక్ట్ చేసి చూపెడతామండి. సేమ్ థింగ్. షూర్ మేడం, షూర్ ఇస్తాను. ఇక్కడ కనెక్ట్ చేయండి మేడం ఎవరైనా. అదేంటి మేడం బాక్స్ ఉంటుందో బ్యాగ్లో ఉందో చూడండి, జెల్లో ఒకటి తీసా కదా, ఇక్కడ ఉంది. ఏది మేడం అవుట్పుటా? ఇది ఇప్పుడు ఇక్కడ నుంచి ఇన్పుట్ కదా మేడం, ఇక్కడికి వెళ్ళి ఇక్కడ స్టోర్ అవుతుంది, ఇక్కడ నుంచి కంప్యూటర్కి వెళ్తుంది. ఇప్పుడు దాన్ని ఈ వైర్ పెట్టండి మేడం, ఇది దాన్ని పెట్టండి. అంటే మనం అక్కడ దేర్ వి కనెక్ట్ మోర్ ఛానల్స్ అండ్ టేక్ 1 or 2 as a reference మేడం, లైక్ దట్. మేడం మన ఫెలిస్టేషన్ లాంటిది ఇక్కడే 2 minutesలో కనెక్ట్ చేయండి, మళ్ళీ ఇంకా అక్కడికి మళ్ళీ అది పెట్టండి మేడం. పుష్ హార్డ్. ఇప్పుడు ఇంకో ఇది ఇక్కడ పెట్టాలి మేడం. సేమ్ 1 frontal యాజ్ ఎ రెఫరెన్స్, 1 somewhere else. ఇక్కడ 1 from the frontal lobe మేడం, సేమ్ ఆల్మోస్ట్ ఎట్ ద ఎండ్ వీఆర్ కీపింగ్ 1 from the reference. మేడం అందులో ఒక ఇది ఓపెన్ చేయాలి ఒకసారి, ఇందులో ఒక పెన్ డ్రైవ్ ఉంటుంది మేడం. చేయండి మేడం. Normally we also avoid with persons with thick hair.
Yes sir.
We can do, but lot of gel we have to apply. Madam ki chala.
And even sticking to the directly exactly this scalp also gives the perfect EG waveform.
Yes madam. Malli entante idi daniki we need to apply lot of electrode gel. No, hair won't go madam, just like a shampoo.
No, I'm telling that I don't have dense hair.
Without architects, if you want,
shall I connect?
Actually, ఒకసారి క్లిక్ చేస్తారా?
మ్యాగ్నెట్ లాగా వర్క్ చేస్తుందా?
ఇది ప్రెస్ చేయాలి మేడం, అయితే చాలాసార్లు పెట్టాం కదా కొంచెం లూజ్ అయిపోతాయి జస్ట్, అందుకే ఏంటంటే చాలా ఓపికగా చేయాలి అనమాట.
ఊడిపోతుందా సార్ మళ్ళీ?
లేదు ఫిక్స్ అయిపోయింది.
sir, these electrodes also will be of different types, no sir, like needle electrode, surface electrode.
ఇప్పుడు ఇంతకుముందు 3 చూపెట్టాను కదా మేడం.
Yes sir.
అవి అందులో ఇది మామూలుగా డైరెక్ట్ ఎలక్ట్రోడ్ డైరెక్ట్ మేడం, కొన్ని ఇట్లా నీడిల్ లాగా ఉంటుంది, అది కొంచెం లోపలికి వెళ్తాయి కొంచెం ఓపెనింగ్. జస్ట్ ఫర్ డెమో కదా సార్, ఓన్లీ మేడం ఏంటంటే ఎలాగో వచ్చారు ఇక్కడ వరకు చూపించేయాలండి అని చెప్పాను. So new workspace we have to create, madam. Every recording you have to make a new workspace. I am creating on the desk. ఇది సేమ్ దీంతోనే వస్తుంది సార్. బ్రెయిన్ విజన్ అనలైజర్ రికార్డ్ దీంతోనే వస్తుంది అన్నమాట.
That will be with the device instrument.
డివైస్ ఆ పెన్ డ్రైవ్ ఇది వచ్చేసి కీ ఫర్ దోస్ టూ సార్.
ఈచ్ మెషిన్.
ఈచ్ డేటా అక్విజిషన్ సిస్టమ్ మేడం.
ఓకే.
సో నేను 2 ఛానల్స్ పెట్టాను. చూడు ఇక్కడ యాక్టివేట్ అయిపోయింది. somebody want to check, they can come here. Now ఇక్కడ ఇది యాక్టివేట్ అయిపోయింది సార్.
Sir, will the hospitals using
Similar madam,
the same device?
Same madam, almost same, just only the specifications and the IN nature is different. Now two I have kept madam. See, the channel name I am checking FZ CZ because previously I used na same channels are there.
Yes.
But actually I am collecting here na.
Okay.
Front.
Each and every channel will have a specific name.
That's why I am telling you. This is FP1, FP2. This fixed.
Okay.
Now FZ CZ previously we have kept channel na.
Yes.
Now if you want to change again we have to type it. That's all.
Yeah.
It is now actually the name is different, but actually they are FP1, FP2. That's all. Next, if you press next, finish. It will show here. Now we have to check something called impedance check. This one, impedance check.
Still not waves of it, madam. What ఇంకా ఇది గ్రాఫ్ వేవ్ ఫామ్ చేంజ్ అవుతుంది అంతే. These are only EEG, not lie detector to detect.
ఏటీఎం పిన్ మాత్రం మనసులో అనుకోకండి.
వచ్చేస్తుంది పిన్నుతో పనే ఉందండి సార్. ఓటీపీలు వస్తాయి. చెప్పండి. మీకు సెషన్ వచ్చిందా?
సో ఇంపిడెన్స్ చెక్ నౌ కాంట్ స్టార్ట్ సర్వింగ్ ద డివైస్. ఇది ఒక్కసారి అట్లా స్టక్ అవుతుంది, మళ్ళీ చేసుకోవాలి. సి ఇది వస్తుందా? ఇప్పుడు యాక్చువల్గా ఇక్కడ చూడండి, ఈ షార్ప్ ఉంటే అది 4 హెడ్, కానీ ఇక్కడ ఎందుకు చూపెడుతుందంటే నేను చూడండి ఆ పేరు చేంజ్ చేయలేదు, జస్ట్ ఫర్ డెమో కూడా. యాక్చువల్లీ ఇక్కడది ఆ పేరు ఇప్పుడు ఈ FZ CZ అనేది ఎప్పటి నేను పోయిన పాత కాలేజీలో ఆ పేరు పెట్టాను, అందుకని ఇక్కడ చూపెడుతుంది. యాక్చువల్లీ ఇక్కడ ఇప్పుడు పేరు మార్చాను అనుకో, అది ఇక్కడ చూపెడుతుంది, కానీ యాక్చువల్గా డేటా వస్తుంది ఇక్కడ నుంచి వస్తుంది. ఇప్పుడు
కలర్ చేంజ్ అవుతుంది.
జస్ట్ కలర్ మనం కొంచెం జెల్ అప్లై చేసుకుని ఇట్లా పెట్టుకోవాలి. కలర్ అంటే కొంచెం జెల్ అప్లై చేసి పెట్టాలి ఇట్లా. మళ్ళీ అది కలర్ ఇంకా చెప్తాను, కొంచెం జెల్ చేసి పెడుతూ ఉంటే వస్తూనే ఉంటుంది, కొంచెం టైం పడుతుంది అంతే. ఇది చాలా ఓపికగా చేయాలి మేడం, అది ఇట్ విల్ టేక్ లాట్ ఆఫ్ టైం. యూ హావ్ టు డూ ఇట్ అగైన్ అండ్ అగైన్. ఒకసారి రికార్డింగ్
లేదు సార్.
అంటే కొంచెం లూజ్గా ఉంది మేడం, పెట్టాలి. అయింది ఇప్పుడు బాగానే అయింది, కొంచెం జాగ్రత్త.
ఒకసారి ఇవ్వండి సార్.
అది యాక్చువల్గా చాలాసార్లు పెట్టాం కదా మేడం డెమోకి, అందుకని యూజ్ అయ్యింది. ఈ వైర్ తీసి ఇంకోటి పెట్టాలి, సరిపోతుంది.
వైర్ ఇవ్వనప్పుడు
మళ్ళీ ఒకసారి చేద్దాం అక్కడ. ఇది ఇట్లా జస్ట్ మానిటర్ చేద్దాం డేటా. చూడండి ఇట్లా ఇది ప్రాపర్గా జెల్ పెట్టలేదు కదా, అందుకని ఇట్లా మీకు ఇలా రావట్లేదు. వెన్ యూ కీప్ లాట్ ఆఫ్ జెల్ అండ్ మేక్ ద ఇంపిడెన్స్ చెక్ సక్సెస్ఫుల్, అప్పుడు బాగా వస్తుంది. విల్ కమ్. ఇప్పుడు అదే డేటా, కాకపోతే మీకు ఇట్లా రావట్లేదు, కొంచెం ఇది ఎక్స్ట్రీమ్ వాల్యూస్ వస్తున్నాయి. సేమ్ వాట్ ఎవర్ వీ హవ్ స్పోకెన్. ఇప్పుడు మళ్ళీ ఏం చేయాలంటే మీరు చూసి మళ్ళీ జెల్ పెట్టుకొని మళ్ళీ చేసుకోవాలి కాస్త. ఒకసారి వన్స్ ద ఇనిషియల్ ఎక్స్పెరిమెంట్ ఈజ్ సక్సెస్ఫుల్ దెన్ ఫైన్. మళ్ళీ ఇక్కడ పెట్టుకోవాలి, ఎక్కడ తక్కువ ఉందో చూసి.
ఈ జెల్ దేనికి ఉపయోగపడుతుంది?
To stick the electrode properly to the either to the brain part.
సిగ్నల్ కూడా ఈజీగా క్యాప్చర్ చేస్తుంది మేడం. ఆ డెన్సిటీ అయి ఉంటుంది కదా కొంచెం ఫ్యాక్టర్స్.
బయట
ముందు ఇంపిడెన్స్ చెక్ చేసి ఎప్పుడైనా వెళ్ళాలి. సార్ ప్రాపర్ వస్తుంది, జస్ట్ వీ నీడ్ టు చెక్ టైం. లేదంటే ఇక్కడ ప్రాపర్గా పెట్టలేదు. యాక్చువల్లీ ఇది హరిహరిగా చేయకుండా నీట్ సాపర్గా చెక్ చేసుకో.
హెచ్డిఎంఐ పిన్ దీనికి కనెక్ట్ చేస్తుంది కదా. జస్ట్ ఇక్కడ స్మార్ట్ బోర్డ్ రావాలి.
బోల్ హెడ్ లా ఉంది.
అందుకే జస్ట్ వస్తుంది మేడం, కాకపోతే క్లియర్గా దానిలాగా రాదు. ఎందుకంటే మనం మీకు ఎక్స్ట్రా జెల్ పెట్టి ప్రాపర్గా చెక్ చేసి చేయాలి, కొంచెం టైం పడుతుంది. యాక్చువల్గా ఇది 2-3 అవర్స్ పడుతుంది, మనం ఫాస్ట్గా చేస్తున్నాం కదా, దట్స్ ఓకే.
Okay sir, we'll leave, not an issue because you need to catch your
అవును మేడం, అంతే. ఇంకా ఇందులో ఏం లేదు. ఇంకా ఇప్పుడు నౌ ఈ జస్ట్ మానిటరింగ్, ఇట్ విల్ కమ్. ఓన్లీ థింగ్ ఈజ్ ఆ ప్రాపర్గా సిగ్నల్ రావాలంటే ఇదంతా నీట్గా క్లీన్ చేసి మళ్ళీ మీరు ఎలక్ట్రోడ్ లోపలంతా అప్లై చేసేసి పెట్టాలి. మీకు ఆల్రెడీ వీడియో చూపించాను కదా, అంతే, జస్ట్ అంతే. సేమ్ మేడం కొన్ని సిగ్నల్స్ చూపిద్దామని, షీ వాంటెడ్ టు సీ హర్ సిగ్నల్స్. నాది కూడా టిక్ చేయాలా? మెయిల్ అది ఎన్ఐటిగోలో ఉంది సార్, మీరు చూసి నాకు కాంటాక్ట్ చేయండి. ఐ విల్ గెట్
Sir, you belong to the department of CSC.
సిఎస్సి మేడం.
From the website can we contact?
వెబ్సైట్ నాది, మొబైల్ నెంబర్, వాట్సాప్ నెంబర్ కూడా ఉంది.
Okay sir.
దామోదర్ రెడ్డి ఎన్ఐటిగో అంటే మొత్తం
Okay sir.
అంతా వచ్చేస్తుంది.
Okay.
వాట్సాప్ నెంబర్ కూడా ఉంది ఆన్లైన్లో. ఓకేనా? సో మేడం, దిస్ ద ఓవరాల్ ప్రొసీజర్. ఆ లింక్ నేను మళ్ళీ మీకు పంపిస్తాను. యూ జస్ట్ హ్యావ్ ఎ లుక్ ఎట్ దట్. ఇది మేడం, ఐఎమ్ షోయింగ్ ద సిగ్నల్స్, ఆల్మోస్ట్ ఇట్ ఇస్ కమింగ్.
Regarding the deep learning fundamentals to architectures and supervised, unsupervised differentiation and all. And today he has given us the insight on the brain-computer interface, where we have clearly saw how the brain-wave signals are being acquisition is done and how they are going to be processed, pre-process and without removing noise and all. So Thank you, sir. Thank you so much for accepting our invitation and giving us a valuable lecture. I would like to invite Principal Ma'am to head stage, sir. So,